Hello everyone. So in this video we are going to understand what are the different encoding methods. So encoding is basically to represent any information, and basically we are using it for transmitting our data or to store our data. So like in our computers we are encoding all the information in the binary form, that is 1 and 0. So whatever we are storing in the machine are actually stored in the encoded form of 1 and zeros. So there are many different techniques which are used for encoding, and we have different kind of encoding like default encoding methods, uniform encoding method, fixed length encoding method, variable length encoding method. So we are going to see all these different kind of encoding method in this video. So let's start. Okay, so let's have a look on default encoding. So this is the encoding method that we use in general to represent our information. We know that all the information that we store in the computers comprises of 0 and 1. So every character that we use, like uppercase, lowercase, and all the numbers or the symbols, plus, minus, now they are all are represented by a sequence of zero and ones. And this a unique uh, sequence for every character is actually described using 8 bits. So bit is 0 and 1. So when we write a sequence of 8 bits, that is representing our one symbol. So, and this we are calling as ASCII representation. So if we want to represent this particular string, which comprises of 1, 2, 3, 4, 5, 6, 7, 8. So 8 characters are there, and for every character we are using 8 bits. So that means in order to represent this particular string requires 64 bits, because every character is represented by 8 bits. Now, this is a default encoding method. Now, the question arises that when we are sending some information, or when we want to store the information, we see that some of the characters are very much used. Means the frequency of sub characters are actually much in compared to other characters. So there we can use some logic where we cannot use the same number of binary sequence to represent every character. We can go with the variable kind of representation, and this will help us to save or reduce the memory size. That is basically called compression. So we have well known Huffman encoding method, which basically reduces the size of any string or any information by doing a variable length encoding. So now we understood what is default encoding. Now let's look to the uniform encoding. Now here we are using less number of bits. So we have seen that 8 bits have been used to assign uh, each character. But now, if we know in advance that the entire information that we want to store or that we want to transmit comprises of a defined set of symbols, let's say we only want to use A to Z. We are not using 1, 2, 3, 4 or any other symbol. That means the total is 26. So we have to see that how many bits are required to represent 26 symbols. So once you understand, so if we have three symbols, that means we can represent 2 power 3. 8 characters can be easily identified. So in this way, we can find out that in order to represent any of the characters, how many bits are required. So what does it mean? It means in our example, A, B, A, C, D, A, D. So we have seen that we are using A, B, C, and D. Only 4 characters are being used to represent this. So if I want to represent in a smarter way, I will only realize that how many bits are required to represent these 4 different characters. So 4 different characters can be easily represented by 2 bits, because with 2 bits we can make 4 different combination. So 2 power 2 is 4, and 4 bits means you can make combination like 00, 11, 10, and 01. So these are the 4 different combination. So we can say that A may be this, B may be this, C may be this, D may be this. Means every character is using 2 bits. So instead of assigning 8 bits, now here we are uh, only assigning 2 bits. So What is the size? Means how many bits are required if we go with uniform encoding method. Now, when I say A is B, C, D, they have a global meaning, and we are saying A00. This is our encoding scheme. Here we are representing A with 00. So if we are transmitting this information to any other receiver, he must be also knowing that this 00 is actually for A, and 11 is for B, and A and B also have a kind of representation, and we have ASCII representation which is globally accepted. So what is required? We need to first send the the actual the default notation for A, means I need to send along with my information. I need to send that this A is basically represented by 8 bits, then B is 8 bits, C is 8 bit, and D is 8 bit. So total bits required is basically the decoding scheme and the encoding message. So when we uh, think about encoding, is not only just to encode the data with this kind of representation, but we also need to think about that the receiver, how the receiver will react to this information which has been received. So when 00110101 has been received, so this is sure we have already informed to the receiver that he has to read the incoming string in a pair of two. That means this 00 represent a particular character, and then 11 represent a particular character, and 10 represent a particular character. So this is already identified and has informed to the receiver. But at the same time, we have to also send the information that A means 00, B means 11, C means 10, and D means 01. Then only the receiver can understand that 00 means A, 11 means B. So this is to be also sent. But when you are sending A, B, C, and D, it will use the default representation, that is 8 bit. That means if we are sending this information, we need to send uh, 8 into 4. That means the 8 bits for these 4 characters, these many bits we have to use. Along with that, we have to also send that what we have used in our encoding scheme, that we are sending 4 1 2 3 4, and for every character we have used 2 bits, means A means 00, B means 11. This also we have to see, also have to send. So 8 into 4 plus 4 into 2, this is basically our decoding scheme that we have used. And then we have to also send the actual data. So here you are having 8 symbols, and 8 symbol, every symbol is using 2 bits. So 8 into 2 is 16. So if you look at the total size, this is 32 plus 8 plus 16, 56 bits have been used. So in the uniform encoding, we have seen that it requires 56 bit, but for the default encoding, it requires 64 bits. So here you can see that we have reduced the size with an uniform encoding, and this size has being visible even when the string size is actually very, very small. It's just a 8 uh, character word. But if you are sending a larger file, then we can see the impact, means how much size you can reduce by uniform encoding method itself. Provided that all the entire things has been comprises of only A, B, C, and D, then only this is has a meaning. Now, variable encoding. Variable encoding is basically makes sense when we are sending a large size data, and also we have realized that some of the characters are frequently used, because this is very general that when we send some characters are very, very frequently used. So the one which is frequently used, we can come up with the logic that these characters which are frequently used are assigned a lower kind of bit representation, and the one who is occurring very rarely, they can have larger bits representation. So uh, let's see that how we can come up with this. So here we can use Huffman encoding. Huffman encoding is basically an algorithm. It's a mechanism where we uh, represent any every character with a sequence of bits in such a way that it fulfills the prefix property. Prefix property already we have discussed in the previous video, that whatever the sequence we are assigning, it must not be prefix for any other representation. What does it mean? It means that if I am saying A is assigned 0, then I cannot say B is 0, 1, because in this representation, this 0 is a prefix of some other representation. So this is not fulfilling the prefix rule. So if I say A is 0, then B must be something which not start with 0. Then only we say that prefix rule is being followed. So here we will uh, use the Huffman algorithm. Huffman algorithm give us the representation that also fulfills the requirement of prefix rule. So let us have a look here how it can be done. So here you can see that we have this string where A is occurring how many times? Let's have a look here. A occurs 5 times, and B occurs 1 time, C occurs 1 time, and D occurs 2 times. So this is, I think, 9. Let me cross check this. So A occurs 4 times. So now this is 8. So we have 8 characters are there. We know how to build our Huffman tree that will help us to generate. So let us quickly do it. So B1 and C1, this will give you a node of size 2. Then we can take D here, and D will be, this will be 4, 2 plus 2, 4. And then we will take A. So we will take A with frequency 4. So this will give a root node with 8. So here we can just quickly write 0, 1, 0, 1, and 0, 1. So we can see here that A is assigned 0. This is A, D, B, and C. So here we can see that what is the how many bits we are requiring if we go with this approach. So you can see that total bits required is decoding a scheme, number of bits for decoding a scheme, and number of bits for encoding message. So here, if you look, uh, the very first thing is we have to send ABCD. That means we have to use this. We have to send this information that ABCD we are using, and this 4 characters will require 8 ASCII bits. This is one thing. And then 9. So 9 actually comes out. So if you look at this, this is what we have used. For A, we are using 0. For B, we are using 110. C, we are using 111. And D, we are using 10. And this is the frequency that we have mentioned here, that D occurs 2 times, C occurs 1 time, B occurs 1 time, and A occurs 4 times. So if you see how many bits are being used, so if you count this, this is 9. So 9 bits we have also we need to send along with this. And then what is the size for representing these bits? So here we have, you can see here that A is using only one bit is being used for A. So A occurs 4 times, so 1 into 4. And then 3 bits have been used for B, which occurs 1 time. And again, 3 bits have been used for C, which occurs 1 time. And then D use 2 bits that occur 2 times. So if you just solve everything, it comes to 55 bits. Now, here we can see that 64, 56, 55, which is not much difference, means it does not shown the big difference, but this is only visible or reflected for a small word that is of 9 characters. Now think about a larger size file, then we can kind of realize that how much how much size of this file can be reduced if we go with this activity. So variable encoding is actually very much used for for the comparison techniques. So let us quickly understand that how we can find uh, the the, fi- the number of bits required for uniform encoding and variable encoding if we want to encode this particular word. So the question is, find the number of bits when we use uniform encoding to represent this particular string, or how many bits are used for variable encoding, and we are using Huffman encoding method. So already we have discussed how to find number of bits in the uniform encoding and variable encoding. So here is the solution. So you can see here that for uniform encoding, we can see that only A, B, and D, 3 characters are to be used. So how many bits are required? So if we use 1 bit, we can represent 2 characters because 2 power 1 is 2. If we use 2 bits, then 4 characters are required. That means in order to represent these 3 characters, we actually need 2 bits. So 2 bits have been used to represent. So in the uniform encoding, what we do, we represent every character with 2 bits. Now, when I say default encoding, default encoding is our general encoding method where every character is actually using 8 bits. Okay, so that actually covers all the possible symbols that actually we are using. But if we know that if our file consisting of only three characters, then we can use this uniform encoding. And in our case, because it comprises of only three characters, so 2 bits are sufficient. Okay, so one thing is only 2 bits are required to send. So how many bits are using for encoding? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a nine size, word. So 9 into 2, 18. This is one thing we have to use number of bits to represent to do encoding. Along with that, we use A, B, D, which is three characters are there. So we have to send 3 into 8. 24 bits also is required uh, to send to the receiver in order to make them understand that we are using A, B, and D for our, A and B and D is being used in this message. So you can see here 3 into 8 is there, and 3 into 2, which is basically we used A, B, and D, and each comprises of 2, 2, 2. So 3 into 2, 6 bits have been used for this, and this is for the actual message. So we have nine characters here. So every character is represented using 2 bits. So that makes 48 bits here. Now, if we look to the variable encoding, so first we need to find out using a Huffman algorithm that how we can going to represent. So here we have already find out that we are going to represent A with 0, B with 1 0, and D with 1 1. And this fulfills also satisfy the prefix rule property. So there is no ambiguity when you decode any of the message using this kind of representation. So here you can see that uh, 1, 2, 3, 4, 5. Okay, so only 5 bits have actually been used here. Okay, so how to how to find the total number of bits which have been used here? So you can see here 8 into 3. We know that why it is 8 into 3 because we have to send the ABD and 1, 2, 3, 4, 5. So this is actually 5. This is not, this is 5. And then what is the size of the bits for this? So we have 1, 2, 3, 4, 5 times. So we have used 1 bit for A. So A used 5 times, and we used 2 bits for B. B used 1 time, and then we used 2 bits for D, and D used 3 times. So if we multiply this, it comes out to be 44. Actually, this is 7. We have written. I think this is 42. So you can see that some difference is still we have visible here that this if we use with the uniform encoding, this much is the size. If we use uh, with the variable encoding, this much is size. If we go with the default encoding, then this size is 9. Then 9 into 8 will be 72. Will be the number of bits required for no for encoding. Okay, so this is all. I believe that you understood. Thank you so much. See you in next video.